Template query is a super strong query method. It not only integrates the features of those past query commands introduced in the previous lesson, but also introduces more advanced functionalities to make the query more flexible. A template query uses N to denote node and uses E to denote edge. Compose a series of nodes and edges to denote the path. This is a template that searches for all the one-step paths in the graph. The result is equivalent to the one-step paths of all the edges in both directions. To compose a simple AB-like path query, write the filtering conditions of initial node and terminal node in the first and the last N, and write the filtering condition of edges in the E. To specify depths, write a number or range in a square brace attached to the E. Don't forget to set limit, define alias, and return class. This template describes transaction paths from card 001 to card 002 within 5 steps. To find the shortest path, use symbol star as the lower limit of the depth range. When hovering a mouse over the metadata, its property values are shown at the bottom of screen. We can also add filtering conditions for the intermediate nodes. Intermediate nodes are denoted by NF. It is always inserted between the E and its square brace. Now rule out the intermediate nodes whose level is less than 3. Direction of edge is also filterable. Use RE to denote right edge and use LE to denote left edge. This template specifies that the money is transferred from card 001 to card 002 and abandons those transaction paths with circles. Regarding the inter-step comparison feature of AB command, which is realized by parameter path ascend and path descend, template query employs inter-step filtering mechanism, which uses system alias privn and prive to denote the nearest node or edge on the left of current metadata. The interstep filters return paths where the transaction time is ascending along the path direction. To realize queries similar to the autonet command, simply set filtering conditions for the first and the last N that multiple nodes will pass. Not only the paths can be returned, a single metadata in the path can also be returned. More complicated path pattern can be described with template. This template describes the transaction paths within 3 steps, from bank cards held by customer 001 and 002 to bank cards held by customer 024. It is a description more detailed and precise than those in the previous examples. Sometimes we want circles, not getting rid of circles. For example, we may be interested in the transaction rings of 3 steps, which is usually considered as a practice of triangle counting. In order to close the path into circle, define alias in the initial n and use it to filter the terminal n. The last feature to introduce about path template is the different treatment when a query has no return. This template describes transaction paths within 3 steps from the bank cards held by customer 021 to any bank card. From the graph we can see such path does not exist. This template query has no return. If we add a query prefix optional in front of a template query or any kind of metadata or path query, then a pseudo result will be returned if a single execution has no return. All metadata in a pseudo result with empty or 0 ID. Template query can handle the situation when there's no path found with the specified depth range. If we write 0 as the lower limit of depth range, and guarantee that the two n before and after this e have the same filtering condition, then when this hop in the depth or these multiple hops in the depth do not exist, this part will be abandoned. The template becomes passed from customer 021 to the bank card he holds, which has only one step. When different path templates intersect at some nodes or edges, then they become subgraph. For a subgraph pattern of our interest, define alias for the intersection node or edge in the path where they first occur. Then use this alias to filter the intersection nodes or edges when they occur again in any template that comes later. This template describes the reuse of phone numbers by cards, which are already used by the cards of customer 013 or customer 020. Attach this template to the khop command. Those cards that reuse the subject phone number will be searched as neighbors of customer 013 or customer 020 on the third hop. This is not achievable if using the parameters of khop command introduced in the previous lesson, since the metadata in the path, excluding the initial node, have different filtering conditions. As the path template which follows the khop command is considered as the shortest path, those cards on the third hop definitely do not belong to the customer, which is the initial node in the path. Otherwise, that card should occur on the first hop. Here is the summary of basic templates of template query, and most of them are covered in the demonstration just now. Let's check the syntax. For a path template, Only basic templates that denote single node or edge can be defined of alias. The zero-length edge only happens when there's no edge available and the two nodes before and after the multi-edge have the same filtering condition. Subgraph query command works by joining different path templates at their intersection nodes or edges, where the path template do not support alias to be defined for the path. The khop command, even though followed by the path template, still returns nodes as its query result. There should be filtering conditions in the initial node of the path template, and the path template should be composed to a fixed length. Do not divide alias in the path template.